Hi everyone, welcome to the Entropy Podcast. I'm your host, Francis Gorman. If you're enjoying our content, please take a moment to like and follow the show wherever it is you get your podcast from. It really does help out. Today I'm joined by Dr. Michele Mosca, a founder of the Institute of Quantum Computing, professor in the Department of Combinatorics and Optimization at the University of Waterloo, and a founding member of the Perimeter Institute for Theoretical Physics and Waterloo Cybersecurity and Privacy Institute. He is globally recognized for his drive to help academia, industry, and government prepare technology systems to be safe in an era with quantum computers. He co founded Evolution Q Inc. to provide services and products that enable organizations to evolve their quantum vulnerable systems and practices to quantum safe ones. He was a founder of the ETSI IQC workgroup series in quantum safe cryptography. His research interests include quantum computation and cryptographic tools designed to be safe against quantum technologies. Mikael, it's a real pleasure to have you here with me, and thank you for taking time out of your busy schedule to join us here today.
Yeah, it's a pleasure to be here with you and your listeners.
You've been in the quantum field for a long time. What first convinced you that quantum computing wasn't just a theoretical curiosity, but something that would become a practical reality within our lifetimes?
My initial reaction was much more harsh than that. I went through, Schopenhauer's three stages of ridiculing, violently opposing, and then accepting as self-evident. And so I initially thought it was science fiction. And then when I realized that people were serious, then I thought, well, they're crazy um, because of all the obvious reasons, right? Partly I didn't know where experimental physics was even in the mid 90s, and it was further along than I thought. Um, but when my advisor at Oxford basically forced me to meet the physicists who were saying that a quantum computer could break the cryptography I was working on, I realized they were only half crazy, and they actually kind of knew what they were talking about, and that fundamentally the laws of physics would allow a quantum computer. Um, and that was part of it. So they're not actually crazy. They're actually really impressive physicists who are working on this. And several of them have won Nobel Prizes in the meantime. And then probably the clincher for me was that by 96, they'd figured out how to do quantum error correction. Because if you couldn't do that, there was no way we'd ever scale this thing. Because even classical computing and communication, if you're in if you're trying to do large scale computations or large communications through even mildly noisy environments, it's not going to scale for very long. So you really do need some form of error correction. And when I realized that people had resolved, at least fundamentally, how to do that, even if it was impractical back in 96, it went from being impossible as far as we knew to just extremely challenging. And over the past, so back in 96, I remember I was asked, when are we going to have a quantum computer that could break these codes? And I was, after trying to avoid the question, I said, look, it'll be more than 20 years. But in 20 years, we'll have about 20 qubits, 20 quantum bits, and the path will be clear. Then we could start making educated guesses, but definitely not for 20 years, which is a bit, I don't know, arrogant. I don't know, or, to suggest it's going to be a 0% chance in 20 years, but I really didn't see the pathway of, even having the tools to build a quantum computer back in 96. And by 2016, indeed, we're in 10 to 20 qubit land. And error correction matured tremendously. So the assumptions underlying quantum error correction had gone down dramatically. It was a much more practical proposition. And on the other side, the technologies for achieving it had advanced tremendously. But it was really in 96 that I realized this is eventually going to happen. Again, it would take more than 2 decades. But that's when the switch flipped for me from this is crazy, why are these people wasting my time, to this is going to work and I need to understand when is this going to happen and what will be secure in the quantum era. So that sort of became my passion in 96.
Can you explain Mosca's theorem to me in plain language and why it matters for businesses and governments in that vein?
My early work was actually in regular cryptography, right? And I was trying to use classical regular computers to break the codes we were just starting to use, right? Because in in the 80s, the few people in the 80s, by the early 90s, less than 1% of the world was even connected, um, and the systems we were protecting were very few and largely with manually pre-shared keys and really primitive symmetric key systems. Um, but by the early 90s to mid 90s, we started using these public key methods to secure the internet. And I was lucky um, to work with pioneers in making that a reality, right? And in taking one of the most widely used methods known as elliptic curve cryptography, uh, and it was better than the first method known as RSA because it's generally we felt it was more secure and much more efficient. But I worked with the pioneers and I watched them take over a decade, close to 2 decades, to take it from an idea, a mathematical academic idea, into a globally deployed product. So I was very intimately aware of the migration time, and I'd seen people try to, even back then, where they were just struggling, even though the systems are much simpler, it was a long struggle to migrate because you have to trust the new stuff. And that takes many, many years for many, many reasons. At many different layers in the stack, it takes time to build that trust. So I knew of the migration time, and I knew of, well, some information needs to be kept secure for a long time. So those are two. So you're not just racing against, and I knew that, the time for quantum computers to get into the hands of adversaries, while it was still a few years away, it wasn't that many years away. But that wasn't the deadline. Like the timeline to start wasn't when is the threat going to be real, like, because it was quickly becoming the cryptography that quantum computers would threaten was quickly becoming not just a curiosity, but the basis for protecting the whole economy, the digital economy, which is now underpinning pretty much the whole economy. So we needed to get ahead of this. It's okay to be a day early, but we could not afford to be a day late. But we had to take into account, well, how many years will it take us to actually, even if somebody handed to us, a code that was secure, which they hadn't, but how many years would it take us to develop this, build the confidence, and deploy it? Right, that's what I call that Y, parameter Y, the migration time. Plus, those last few encryptions need to be secure for some number of X years, right? And you want the collapse time, the time before threat actors are able to exploit quantum computers to attack these systems, break the confidentiality, and so on, to be less than the sum of those two numbers. So that's sort of the Mosca equation, and it became the foundation of quantum risk management or cryptographic risk management more generally. And it motivated the first people to take it into account were those who were worried about long-term confidentiality and the so-called harvest now, decrypt later attack, where we're assuming that information is being recorded, not necessarily everything, but we're assuming some information is being recorded. We don't, adversaries won't tell us which information they're recording and how, but we know it's happening. Our governments are telling us it's happening, right? So that was sort of the initial motivator. But at this point, it's really not clear if the migration time, forget about long-term confidentiality. Will the existing systems still be able to operate reliably? Can we even trust our systems, in real time? Are we going to get that migration done before the threat becomes real? And I don't know anymore. There's a significant risk of that Y is greater than Z. The migration time is greater than the threat timeline, not even factoring in the number of years of confidentiality you want.
And I think that brings me nicely. So you 96, you said 20 qubits for we're even near any kind of risk form here, and that's going to take us 20 years. As we approach 2026, and I suppose the date of Q day, as we're calling it as an industry term, is still an unknown quantity. But as you sit here looking into 26, do we have another 20 years? Do we have 5? Do we have 10? What's your take?
Yeah. I mean, and to the cynics who say, oh, it's always 20 years in the future, that's just provably false. You can go over all the past statements, and It went from 0% chance in 20 years down up to now it's over 85% chance. So back in 2015, I started being more public with my risk estimates because the risk was starting to become material within timelines we were not on track to address. And in 2015, I said there's a 1 in 7 chance of this happening by 2026. So to be clear, I said probably not. Like, I'm very aware of how hard it is. I've been working very closely in quantum computing, at, many levels of the stack and with the leaders in building them and programming them. So I knew that probably not by 2026, but I didn't think it was a high confidence, probably not. I really thought there was a 1 in 7 chance that there were enough, unforeseen advances to make it happen. And we have 1 year left. I would say the chance is now less than 1 in 7, which is usually what happens when something is a 1 in 7 chance. It eventually goes to 0. And with 6, 7 chance, that probability goes to 1. But I also said, there's a 50% chance by, I think, 2031. Okay, so, and that, I've been updating those numbers. And I've also now, it was a lot easier to make this prediction back in 2015 because most of the probability was concentrated on one of the front runner platform, the superconducting quantum bits. And there's a few other platforms, but, maybe it added a 25% to the core probability. But now we have 6 to 7 families of platforms, and 3 of them are well into this era of quantum error correction I alluded to earlier. It was a hypothesis in a very speculative hypothesis in 96. I knew it would work, and a few believers knew it would work, but now it's been a validated hypothesis by 3 different platforms and soon a 4th. And there's 2 others, the spin-based approaches that are coming up from behind as well. And that's not even counting the Microsoft Majorana fermion approach. So regardless of your views on that one, that's not what's materially moving these probabilities I'm talking about. So it's much harder it was hard enough to kind of have a view on superconducting qubits, but now trying to juggle in what about these other 3 or 4 neutral atoms and ion traps and so on, different ways of trying to harness quantum information in a scalable, physical platform. So I've turned to my friends around the world who are pioneers and leaders in making it happen and asking them the same question. So it's not just my view, but we have the view of several dozen other thought leaders who really have the big picture view and are really, wanting to neither overestimate nor underestimate the likelihood. Bottom line, when you boil this all together, my personal assessment is, and this was my assessment, about 10, 11 months ago. I'll be updating it shortly, later this autumn. So this is actually conservative. But, 10, 11 months ago, my view was there's a 10% chance of all the pieces coming together in 5 years and a 30% chance in 10 years. And it's gone up actually non-trivially in the last 12 months, but I want to stick with my last year numbers and update them in a few weeks this autumn as I get sort of the last few bits of insight and data, but it's gone up. There's been really impressive advances in the last few years. So again, we've had some of the largest IT companies in the world state aggressive roadmaps in terms of moving into hundreds of these sort of error-corrected quantum bits in the late 2029, like by 2029. One company even says 2028, 29. And there's several very, very well-capitalized, serious companies saying we'll be within striking distance, if not at cryptographic relevance in the 2020s still, like before 2030. So you could say, well, 10%, let's hope for the best, or 30%, let's hope for the best. But the stakes are far too high. So for some systems, sure, you can accept that risk. But when the impacts are catastrophic, that risk needs to be mitigated and really urgently.
And Michael, that's great insight. I thought I was going to get an inside track there on the new numbers. I was waiting with anticipation, but I won't hold it against you for not letting it slip until you have all of the data together. when I look at the guidance coming out of Europe and I look at the mobilization efforts, I see it in two fronts. I see it governments and financials are kind of where the momentum is building at the moment.
Yeah.
But many organizations are still waiting, and it's a kind of it's a next year problem, or it's the next guy's problem. When you talk about a quantum relevant cryptographic computer and you talk about scale, the day this problem gets cracked, is that the day we need to worry, or is it the day this problem gets cracked and that compute power is scalable at a commercial level? Is there a differentiator there?
Um, there is a difference, of course, but even the first state is material, right? Because then, those first few threat actors who will use it, um, they will still go after really fun things that are very fundamental to our freedom and sovereignty and prosperity, right? Because some people might say, well, they're not going to come after my bank account. Sure, but if they go after your bank or your central bank or your government, these indirectly, have profound impacts on citizens. Because it'll impact, it'll impact the cost of living, and so on, and our safety and security. Even if those threat actors aren't necessarily going to go after any one individual, they'll go after really critical systems that we rely on indirectly. And the other thing I would point out is the gap between the first available and second available, where maybe it's heavily controlled or we don't even know about it, to being, then it's going to, these large IT companies are not building quantum computers so they can hide them, right? There's a growing number of business cases for how this technology can create real commercial value, real economic impact, like really material geopolitical shifts based on who can harness the power of quantum computing. And you're not going to do that if you're hiding it, right? So just think back to the British. They developed Colossus, right, to break the fish codes during the Second World War, but then they kept it classified. They dismantled it, kept it classified. They didn't develop a computing industry. They sat and watched the United States do that, right? Obviously the global role of the UK diminished and that of the United States continued to rise, not only for that reason, but that was a certain part of it. So nobody's going to want to hide. They're going to want to use it. Of course, they're going to control it and have a know your client, but it's not going to work, right? Adversaries are going to get on those platforms. If the good players have access, adversaries will get in, and the more you try to restrict them, the bad folk, from getting access, the harder you make it for us to create value with it, because it becomes very expensive and impractical and slow for us to develop all these other sectors, advanced materials, energy, healthcare, and so on. So I don't think there's going to be a multi-year time lag, like there are many years of time lag between those first few actors and it, getting into the hands of negative adversaries. And it's something, I think go very rapidly, and it's largely out of our control. So we just have to not be afraid, but just be ready. We actually know how to create cryptographic resilience. So if we want to benefit from AI and quantum and all these things, we don't need to fear their code breaking capabilities. We just have to architect our systems to be resilient against them.
And I think the message of cryptographic agility has come true. I was talking to a few people lately, and I think yoga was referenced in terms of agility for your cryptography stack, and a couple of analogies like that to try and bed it into the non-technical folk in terms of being able to flex your cryptographic muscles within your organization. You've talked a bit about when this happens, there could be catastrophic type events off the back of it. When I think back to Y2K, we had a deadline and we had an impact. The impact was after this date, everything that uses these underlying systems will just stop working.
Yeah.
Quantum won't stop systems working, but it'll break confidentiality. It'll break trust. What do you see as the biggest problem for companies, businesses, governments that don't act now, that don't build in that agility at this point?
One of the reasons I tend not to use the Y2Q term Because while there are some valid parallels with Y2K, there's a lot of things that are very different. So it can help, but it can also confuse because it will be something that just gradually ramps up. And honestly more worried about, I'm very worried about the known code breaking capabilities, and we might not get ahead of them in time. And I'm even more worried about the next one, unless we architect for resilience. And agility is a fundamental part of resilience, and it was a buzzword in the technical community for over a decade. And now it's in NIST documents, and all the high level guidance is providing it. Now, I guess another thing that is worth noting that's changed, because fundamentally, people don't change their behavior because they see the light. They change their behavior because they feel the heat. Now there's the heat caused by your systems collapsing, but we don't want to wait for that. But I think there's a lot of heat already, and that regulators and authorities and customers even, are asking. They want, if you want them to trust you, you better be quantum safe or have a really compelling story that you're going to be in time. So, and that actually drives businesses to act, right? It's more well, I don't like the checklist compliance approach, but people need to be compliant to be able to continue operating and maintaining their customer base. And so you're seeing all these signals that you have to do this. You better at least pretend to have a plan, and you better quickly come up with an actual plan. And I still see some of the largest FIs in the world where they're like, we're still figuring out who's in charge of it, which worries me a lot. Now, most I would say have somebody in charge, and it worries me if it's one person as well. I mean, this is a multi-faceted team that cuts across all the business lines. Anyway, so the biggest threats, again, we can talk about all the different terrible, so let me break it up into two. So I've kind of outlined all the risks of not being compliant, of not maintaining trust. Like you lose your customer base, or you lose market share if you're a laggard here, right? Like your business, your Christmas bonus might go down, like your short-term career is at stake. And these are the things that generally motivate people more. But in terms of, and on the cyber risk side, of course, it's not just about confidentiality being leaked and maybe paying some fines. Your systems might not work, right? If you compromise the authenticity and integrity of auto updates, for example, right? Like in the zero trust world, like we still need strong cryptography. That's what it allows you to distinguish malware from a legitimate update. And you need the updates because otherwise you don't fix critical security flaws. But if the updates are malware, then your system can go down. Or again, especially in the financial sector, even if the system is fine, but people don't trust it, it goes down, right? How many times have you told people how cybercrime works, and they have this panic look in their face, and they're saying, should I take out all my money and put it under my mattress? And you're like, no, don't do that. But that's not the answer either. So you need people to retain trust in our systems and our institutions, right? So, and if there's real material loss risks, if cyber attackers have these capabilities, and it's on the integrity side. If you have IoT, in financials, we're less concerned about, driverless cars or connected, or drones and whatever. But if you are in the IoT space, you could lose control of these devices as well. So there's a wide range of risks beyond confidentiality as well that one really needs to worry about. I do want to just elaborate on one thing you said, because things, both of us from the technical side, we tend to highlight the technical buzzwords, like you need agility, you need PPC, and so on. And I think the business world says, do I really? I don't think so. I need resilience? Yeah, I guess. And that's almost too high level, but I need to maintain the trust of my customers, right? I need business continuity, right? I need to maintain my market. These are things I need. I need interoperability, right? With all my key stakeholders and so on. So we need to do a better job of translating. And, of course, in the technical world, we're like, well, yeah, of course you want that. But to deliver it, you need agility, you need defense in depth, you need PQC, and so on. So you need to do a better job of translating, connecting the dots between the technical solutions to enable that resilience and the business needs, and also prioritize them. But I do think, agilities, I think we're pushing, we're trying to clarify that the ultimate game is resilience. Agility is an important part of that, but agility is not helpful. Is only like the event, like we have to be ready for an unforeseen, unannounced break of our cryptography. That's the only way to proceed in the modern era with AI and quantum and all the dependencies we have. And so agility is great if it's a recoverable event, right? So you need a combination of agility and defense in depth. And for information assets with a long shelf life, then you need to do the old school symmetric key stuff, which banks and governments still do today. And we need to look at ways of making them more scalable and to, fit in elegantly and simply with all the other, basically the more publicly approach with leverage now.
It's a fascinating perspective. And when I was listening to you earlier in the conversation describing the Mosca theorem, it was coming to my mind. You're the CEO at the side of a desk. Someone tells you about this quantum thing, and you go, what does that mean for us? What does that mean for our organization? And then you look at your technology landscape, and you've got cloud, you've got third party vendors, you've got private cloud, you've got physical infrastructure over here, you've got different service lines. And as the CEO, you go, okay, what's the impact? And the guy looks back at him and goes, well, we don't know yet. That length of time to prepare, people are going to have to build inventories. They're going to have to do architectural dependency mapping. And the cost is going to be significant because you're going to have to refactor applications and all sorts of things. Your routers and switches may not be able to handle the quantum resilient protocols, etc. That they may need to be changed out or beefed up, etc. So if you're that CEO sitting at the desk and you've just heard about this problem, Michael, do you have a stepped approach to quantum readiness that you could give some insights on?
I think step zero, because again, technology people will tend to jump right into, you got to start your crypto inventory, which I think is a critical part. I think one should actually start it right away. But the zero step is do a very quick strategic assessment of your posture. And what do I mean by that? Because there's a technology component to getting to the other side of this one threat and really emerging more ready, because we're really, really lucky that we had over 30 years advance warning. We need to be much more ready. So you want to address this known threat. And when you're done doing that, know that if this ever happens again, we'll be okay. I'm not saying it'll be easy and there won't be any negative impacts, but we'll at least have a recovery plan. So you need to get there. And the technology side is just one of the work streams. There's several other work streams, and you can very quickly, and there's guidance that's out there, and there's, my team can help, and there's teams out there that can help. But you want to do this quick. This is a few weeks exercise. This isn't some super expensive long-term. You, in a very short number of weeks, you can quickly assess what your strengths and weaknesses are in order to get ready and start coming up with a real strategy that integrates, again, and you have to adapt it to your business. We can give you the building blocks of a strategy, of a cryptographic resilience strategy. You can quickly adapt it to your organization and then prioritize your next steps. And inevitably, one of those steps is start, more proactively managing your cryptography with things like a cryptographic inventory. And depending on the nature of your organization, there's several ways to do that. But I think before that, or in parallel with that, I would do a very rapid assessment of your organization to understand how do you govern cryptography today, right? And so on. And to really because you need to understand what's your migration time as an organization. So you have to very quickly assess how your organization currently manages cryptography, to assess how long it will take you and what your weaknesses are that you need to start in a prioritized way addressing.
And I think that will mean for a lot of organizations having to build competency back up in the cryptographic space. I think cryptography is one of those areas that if it's not broken, don't fix it, and has been in security for a long time. So I think a lot of organizations are going to
Yeah,
look at this problem and go, "Geez, the guy who managed that thing is, he's 65, he's retiring next year. who's gonna take it
yeah,
over?
yeah,
Do we need to
yeah.
start building up apprenticeships in this space and getting more staff skilled up in the cryptographic? How do you? What's the quickest way to get your organization cryptographically aware and build up niche skills in these areas, because it's quite a dense field to get into at the start.
I mean, the answer is your cryptographic sort of center of excellence. That's kind of the sweet spot. I mean, yeah, versus this isn't some lone wolf operation that just gets it done and you give him or her an award at the end. Like you do need a broad team. So you need a center of excellence that again is connected to the key pillars of your organization, the business pillars of the organization to get you the other side. And I think it's important to um, don't take the like I wouldn't do a boil the ocean approach. Um, I would so some people made the mistake, and now we're saying we told you so, but they're saying, oh no, like the steps are first I do a cryptographic inventory, right, and then they looked at all these technological means, fancy, some are fancier than others, and their heads are down. Great, I got to get my inventory, and then I'll start assessing my risk and my migration path, right? And it's like no, you can immediately you can ask yourselves, what are my most critical systems that depend on IT? And all your systems depend on IT. And you can, with a couple conversations, like we do this in 6 weeks, and most of that is scheduling meetings, right? You can figure out where your most vital cryptographic dependencies are based on what you already know without even scanning your systems. And you can start doing something about those systems right away in parallel with more, because you do want to get to the other side of this where you can have a more automated way to know that you've mitigated and convince other people that you've mitigated and so on. So you building up your cryptographic inventory is a no regret activity, but you immediately start with business risk, your cryptographic risk assessment, starting with your critical business lines. So you got to start doing, and that gets your risk teams involved. Inevitably, they have to talk to different business teams. So you want very quick projects, again, that you measure in weeks, not years. Start getting things done. Start migrating some systems, even if it's a test system. So you need a handful of these, and then you'll have a more visceral understanding of what this is. Otherwise, it'll just remain this abstract problem that you're kind of admiring almost academically. But it's not. This is not an academic project. This is a really critical, uplift of your organization. And the best way to learn is if you're experiential learning, so start doing some projects, help people understand what this really means, and they start figuring out who they can quickly start making the right partnerships and relationships in the ecosystem. They can start engaging with their supply chains, but I would do it concretely, and not this isn't some abstract. This isn't the PhD thesis you're writing. You have to really get this done. So I think I would start doing a few things rapidly, and so then you can better plot the rest of your journey.
I think that's really good advice. Kind of get a fail fast approach in, test your water,
Yeah,
see, and that will build competency as well. There's one thing you said earlier on, Michael, and it was around this is not a one person problem, and I worry when it is. And what I see when I look at the industry is this has become the problem of the CISO in most organizations. Where
yeah.
where do you think this should sit in an organization, or where would it fail if it doesn't have that top down, bottom up support?
I mean, the CISO is obviously a critical player in this, but they need a team approach. And I mean, every organization's different. You need to structure the team in a way and the accountability in a way that works for your organization. But you can't give them the responsibility to get it done, but not the power and the tools to get it done. So like our first few quantum risk assessments, often it was for a risk team or cyber team, but then we'd have to go talk to other teams, the business side, and they were often too busy and they didn't report up to this person and they didn't want to share this. And we were very, very sensitive to that. So look, we don't need to touch your systems. Like, so even then it was really hard because it wasn't a whole of company effort. So they're going to need the endorsement from the top. I mean, the CEO has to, make it clear we need to do this. Of course, the CEO doesn't need to do most of the lifting, but it needs support all the way up to that level and the board risk committee and so on. They need to work closely with their CIO or CTO, depending. Of course, in smaller organizations, so, it might all be the same person even, but they do need high enough support where they're plugged in to the key business lines and have the support there. So it's not viewed as just a technology problem. Why didn't you get this done for me? It's really critical to the success of the business. So you need enough business support to be able to prioritize it and get the essential pieces done. But I mean, the CISO, you can't be the person in charge of firefighting and fire prevention at the same time, without, a lot of help there. This can't be something you get done in your spare time. It's got to be a critical KPI and it's got to be shared in some effective way with other elements of the company.
I fully agree. Yeah, it's going to need dedicated resources and attention, and it's potentially going to deprioritize and break stuff along the way. That it's going to need a team coming behind, picking up the pieces. So it's definitely going to be quite transformational for a lot of organizations. Michael, that was really insightful and a lot of good insights there for listeners to take away on. Before we finish up, outside of quantum's ability to break modern day cryptography, is there anything that really excites you in the field in terms of its application?
There will be two things. One is it's forcing us to rethink how we manage cryptography, which honestly, a small handful of visionaries have been saying for a long time, but nobody's listening because there was no real threat. And normally, throughout the history of humanity, emerging threats are managed by you wait for them to be, again, to be, the heat to be turned on versus the light to be on. And that doesn't work when the threat is existential or, at the very least catastrophic. And quantum was this blessing in that the impact, if we're not ready, is in some sense existential or catastrophic, but it wasn't, immediate. So it gave us time to really bolster our cyber immune system, and even, give us time to think about, okay, how do we create resilience and agility, and how do we scale symmetric key infrastructures to complement these public key infrastructures, and how do we harness future quantum networks, right? And how do you balance the urgent and sort of the more, emerging things that also need to be handled. And honestly, in terms of the positive impact of quantum technologies, apart from, quantum communication networks being an enabler of fundamentally new cryptographic tools, which will serve us very well in a zero trust world and should be thought of as augmenting what we have, not replacing. Because often in the weeds, people get in this adversarial framework, or what they're doing is the greatest thing ever, and everything else is nonsense and a distraction. Like for the history of cryptography, ever since I've been in, it's been like that. It's not very constructive. So obviously, quantum networks enable, and there's the ones we know about, and there's new ones we're still studying. So that's exciting part of the future, and it's not there to replace the techniques we have now. It's just meant to augment them. And then in terms of the use cases for quantum computing, 5 years ago, I felt that, there's a handful of, potential applications of quantum computing in industry. And my gut feeling was like, at most 10% of them were really ever going to pan out, made a lot of sense, or were likely to work. But that doesn't mean it was a bad exercise. Because you're trying to, harness this new emerging capability that we're still trying to understand. So don't be disappointed if your first few attempts don't work. That's part of the process. And back then I said, like, maybe 10% of these would work, and there's only a handful of people trying. Now we have many, many more people trying, much more sophisticated tradecraft, looking at many more use cases across many more sectors. And maybe it's 20% that if I look at it critically, I would think, yeah, is this really going to hold water long term? So, people, there's a tendency to focus on the 80, the stuff that isn't going to work and say, oh, it's hype and nonsense. I don't think that's, I mean, be critical, of course, but don't be cynical or skeptical. Use that as a guide to steer you toward that 20%, which I think will soon be 30% and 40% in a small number of years, especially as the larger and larger fault-tolerant platforms become available so we can actually test things better. So I'm excited about the positive applications of quantum computing, and the point of of establishing cryptographic resilience while we still can is to make that a positive day, right? Or a positive, well, emerge. I said I don't want to pick one day, but I mean metaphorically to make the emergence of more and more powerful quantum computers with a really exciting value creating opportunity. And we manage it like any other HPC is, and not like this terrible threat anymore. But if we want that, we do need to architect for cryptographic resilience. We know how to do it. And there's really, you were referring earlier about the costs and so on. Well, if you get ahead of this and you structure this as part of your regular life cycle management of your technology, it won't be that expensive, actually. It gets expensive if you procrastinate to the point where you're managing it as a crisis, right? And then you're rushing, and then you have to, interoperability is at risk. Legacy customers and with legacy systems, you might have to just let them go because you can't have both, and so on. So you won't have to make these tough decisions, or you won't have to make many of these tough decisions if you're proactive and knock this into your technology lifecycle management and your supply chain management and so on. I mean, maybe another possibility that might work for some companies is think of this as an extension of vendor concentration risk and supply chain risk, because they're all using the same cryptographic tools and libraries and so on in many cases. But it's like Uber concentration, because it's not just one vendor that is being used by 30% of the world or 50% of the world. It's all of the vendors would be susceptible. So think about how to incorporate this into your existing risk management practices, get ahead of it, and focus on the positive applications that quantum and AI and whatever else is emerging will bring.
I think you nearly got a whole podcast episode without mentioning AI, so you just broke the duck on that one.
Yeah.
Michele, it was absolutely lovely having you on, and I think this conversation has been fantastic and really insightful, so I hope people get an awful lot out of it. But it was a real pleasure speaking with you, and thanks for taking time out of your busy schedule to come on the show.
Thanks, Francis.